Let's officially start with this webinar, Stockpile Volume Calculations, Fast, Easy and Accurate. My name is Marco, I'm from 3D Survey team, and today I would like to show you how elegant, how reliable you can actually calculate volumes with new technologies and so on. I'm sure attendees will still join in the next few minutes, but not a problem. I can tell you right now that this webinar is being recorded. So if you would like to see again, if you didn't understand or anything like that, you can always watch the replay. So after the webinar, you will get a replay link and so on. Not a problem. My second thing I would like to share with you is take some notes and pencils or anything like that. Write your questions down or mark something. There will be a lot of interesting things. Maybe I will go on some steps a bit faster through, and if you don't understand it, just write it down, ask later. We have also chat box options. So on your right side of the webinar platform, you can write your questions inside, and I will try to answer them with during the webinar or at the end of the webinar. The webinar will take us approximately 1 hour, and yes, if there are any questions, feel free to set them. Hope it will be interesting for you, and let's go to our first slide. So it's an overview, what we're going to see today. Actually, the main purpose of this webinar is to show you how reliable, easy, safe, and fast volume measurements and calculations can be. First, we will look at the problem slide and, of course, solution. We all know traditional surveying walkthrough methods are time-consuming. We need more days to complete simple project, which is not even too big, and we need more manpower on field. Modern technologies are super elegant and 10 times more accurate in comparison to traditional one. Then we will have a look about the problem and solution. So we will give you explanation how it works. We will see also which trainings are available. So just a second. So this one actually equipment and software which is going to be used, and the third one will be training. We will have quick workflow from images to 3D models and orthophoto, and in our second real case example I would like to show you how easy and reliable is calculating volume in photogrammetry software. And then the last point of our webinar will be Q&A, so chance to ask questions or anything like that. So if we start with our first point, what's the problem? We all know traditional surveying with total station and GNSS systems is time-consuming, and it takes more days and more manpower on the field. Even if you have a terrestrial laser scanner or anything like that, in areas like that you can see on your on your left side, it's pretty difficult. You need to spend more times to get a complete site and so on. To measure an open pit mine, as we can see on image, it can take up to 2 days if you like to measure it accurately enough for using the data for volume calculation. There is a super elegant solution for you. With the help of drone and photogrammetry software, you can speed up the field work for up to 10 times. You can get super accurate and reliable results with the photorealistic presentations, which can understand everybody, even if they are not construction workers or surveyors. So we know all those vector lines, areas, points. It's kind of really difficult for someone who is not in this business to understand how it goes. But with a photogrammetry solution, the image is the main input and everything is pretty visualized. So imagine to measure a site like this in less than 1 hour, more elegant than any time before, and speed up the rest and spend your rest of the time free at home or maybe finish 10 more projects in the same time and earn money. So in this way you can keep your customer satisfied, authorities happy, and ease your mind. Let's have a look what kind of equipment and software we use for this. So first is equipment, let's say drones. I would say any drone with good camera works with most photogrammetry softwares on the market, but some of them deliver better results in the name of accuracy. Okay, definitely the best seller and the most user-friendly drone for mapping at this time is Phantom 4 RTK, which costs less than $5,000 and has already integrated RTK GNSS on it. This means that you can measure measure the site almost without ground control point targets. Really user-friendly drone. We warmly advise our customers to use Phantom 4 RTK or similar drones because it's just the tool for daily use. Okay, then today we will see what kind of results we can achieve with the Phantom 4 Pro. So this is not the RTK, it's a Pro version, also really good one, a bit cheaper. It costs approximately less than $2,000. And in our this will be shown in our workflow presentation. And then in our second example, we will calculate stockpiles. We will see the results from Matrix 300. So this is actually the black one. Let me mark it. So this is the Phantom 4 RTK. You can recognize it with this small antenna on it. That's why it's RTK. And then the bigger one, it's Matrix 300. Of course, more expensive one, but good one for bigger sites and more advanced projects like inspections or something like that. Okay, so this was all about the drones. Of course, there are a number of them, but let's focus mainly on those two. And then we will have the photogrammetry software. We will have a look at all-in-one solution. Software where you have a processing engine based on which you can calculate point clouds, orthophotos, and 3D models, and functional part. So this is the second part, integrated in the software with option to calculate volumes, creating new surfaces, calculating contours, profile lines, drawing 3D CAD lines, and much more. So all this is integrated in a single software. This just gives you better efficiency by work, and you don't need to buy additional modules or export, for example, the surfaces from one software to another and calculate volumes. So this is a really important point. If you have everything in a single software, you're just more effective, doesn't hurt your wallet so much because every model costs 3,000 plus 3,000 plus 3,000 and so on. And if you have some external softwares or something like that, you will always have some trouble exporting the data, importing them, setting the coordinate systems, and so on. So we will see a simple solution which was developed by surveyors to surveyors with an easy workflow which offers you a high accurate and reliable results even if you are a beginner. So you will see in my first part on software presentation the complete workflow from images to 3D model and orthophoto. I did a screen capture video, so it will go faster through that we don't need to wait in between of the steps, because some of the steps can take 20, 30 minutes or even 1 hour. And just to be more efficient today in this webinar, I captured this in a short video which takes approximately 20 minutes, and we can see how it goes. And then in addition, if you need to measure same terrain, construction site, stockpile, open pit mine, garbage dam, or similar projects, more time to be able to compare the results over time, or you would like to compare already finished measurements done with the GNSS or total station with photogrammetry measurements, there is no better tool available on the market. So this will be presented at the end. where we will actually create a surface based on traditional measurements, GNSS measurements. So this is another nice advantage of this solution. So you can actually combine traditional measurements with photogrammetry. You can import not limited number of point cloud surfaces, anything like that. Okay, here on the screen we already see the volume calculation, how it looks like photogrammetry way, and let's see what kind of training we are on in next few minutes. So first we'll have a look about the basic workflow from images to 3D models, and then after this we will have a look of available options, how easy and reliable is to measure volume based on photogrammetry data. There will be 3 examples. The first one will be just easy selection and calculation volume with one plot. Then the second example will show you how to select your stockpiles or area of interest with the CAD lines, which we created in 3D survey. And then the third example is, as I already mentioned, comparison of the volume with old tachymetric measurements and new photogrammetry measurement. Okay, let's go and see a video with the presentation. Hopefully you can hear it fine. Okay, after we land with the drone on a field, we have images on SD card, and we have a file with ground control point targets, which we measured with GNSS instruments. In our case, we have actually 65 images, which we already imported from the SD card to our local folder on my computer, and also we transfer the GCP file from GNSS device to my folder, and we can see 4 ground control points and coordinates here. Okay, we are already ready for 3D survey processing, so let's turn on 3D survey, and we simply start with new project. We browse to our folder, simply select all the images. We can use Ctrl-A with a keyboard, click on open, and we get the telemetry importer here. What we can do here, first we can select our UAV model. In this project, our customer used Phantom 4 Pro drone. That's why I will select EXIF data. And this selection is usually used in, let's say, 99.5%. So most of the drones are able to write positions during the triggering camera in images, and this is so-called EXIF data. We have also some predefined settings here for some special fixed wings, and if you have maybe like external file for telemetry data, you can go with other and import anything you like. But this EXIF data is just the simpler and safest way. I will select this one. Then the second thing, we need to set our coordinate system of a project. We are somewhere in New Mexico, so I will select this one. If you click here on more, you have here more than, I think, a bit less than 5,000 coordinate systems. So quite a lot of options. So you can always work in your local software. And I think this is our 2258. And just confirm it. Let me see. Yes, this is it. Okay, cool. So you can select your local coordinate system, vertical coordinate system. Let's leave it like a global GeoID model. If you have your local GeoID model, you can also import it and so on. I'm ready to click on import. Data was successfully imported. Click on OK. And here we can see already all telemetry data which you read from the images. So here we have image name, then latitude, longitude, altitude from the drone when was camera triggered, and then immediately transformed coordinates in our local coordinate system, and of course some accuracy during the flight. I'm satisfied with this one and click on close. Here we can see how the drone flew during the flight. So that way, if I zoom out and maybe change my view to standard, we can see that we are located somewhere near Albuquerque. Okay, let's go back to satellite view, zoom in, and it's a nice stockpile under it. Another option is to go to telemetry view. Here we can immediately see how the drone was flying during the triggering and how the cameras were triggered. I can see that the camera is pointing a bit forward. Probably the customer didn't know that the camera is a bit forward, but it's still okay. Most of the cases, users trigger camera perpendicularly down, so 90 degrees down, and in these cases you are the most effective and you get good results. If you are turning camera forward, you're usually doing double grid mission to get even nicer 3D model, but for that kind of projects like we have it here, if the camera is fully down, it's already okay, and it's the fastest way. Okay, as we can see it here, 64 images, and on the right side, below here, we can see 3 main steps for the processing part. The first one is bundle adjustment, and with the bundle adjustment, we actually search approximately 30,000 interesting points on each image, and then we try to compare them between images and try to connect those type points together and get complete model from all 64 images. If I click here bundle adjustment, the bundle adjustment pop-ups come up. We have different mode options. Usually the software is designed so that the default values are the best one, the most proven, and so on. And if there are additional ones, like we have it here, the default is global mode, which is the fastest and suitable for large data sets. Then we have in addition hybrid and incremental. Incremental, it's interesting if you have handshots, which is where we don't have such a great overlap, or we have bad texture like glass areas or anything like that, which is a bit slower and suitable for smaller data sets. And then we have a hybrid options, which is combination of those two. But let's leave it like default on global, and I'm sure we will get great results with it. Then we have here show more and a bit more. So here we can see how many feature detections are we looking on each image. Don't worry, this is everything automatic. You don't need to click anything. So the software works perfectly on this part, and it's pretty fast, as you will see. Okay, let's leave it as it is and click on OK. And we already start with the first step of the processing, bundle adjustment. On my computer, so I have here Asus, I think Asus ROG Zephyr computer, which is pretty small, pretty powerful. This will take approximately 5 minutes or even less. The progress bar will be realistic here after 7%, so we can see it here a bit more than 2 or 4 minutes maybe, and we will back soon. Okay, we are back again, and it took us actually a bit less than 4 minutes, and we can already see here a nice representation of terrain. So our stockpile in the middle, up here are already orientated cameras. I can turn off the text if I like, and we are ready for our second step, a so-called orientation. We will do orientation with ground control points. This drone, it's pretty nice for mapping. but still doesn't have already a RTK drone, RTK antenna, so we need to use ground control points for orientation. I will click on Browse and import those GCP points. As we already saw before, we have 4 of them. Here they are. I need to change my delimiter to comma. And here we have a name, easting, northing elevation. For US countries, I need to switch between easting and elevation. So let's do it like so. Easting goes to northing and northing to easting, elevation, and that's it. Click on import, and here we can see our coordinates confirmed with next. And what we need to do now is we need to show to the software our positions of ground control point marks. So in this case, the user use white crosses. If he would use a 3D survey target, which is actually black dot on white plate, this step will go fully automatic. But nevertheless, in this case, I need to show to the software where my markers are. I even don't need to know which market is which number, so I don't need to know if this is 3 or 4 and things like that. I just use left mouse click and show the center of the marker. Right now I'm doing this just on a single image for first 3. So here is another one. And after I select the third one, the software immediately show me so rough accuracy of this orientation. And if I go with the next image button further to search for the fourth one, we can see it's here, so the geometry is okay. That's why I need to click on confirm unknown markers and improve the position of this one. Left mouse click, the position is improved, and confirm it. Because I don't have here my 3D survey target, I will select every marker on at least 2 images. Now I will just click here, this is number 3, because the software writes me also here the number of waypoint, and do like so for the 3 others. So the 4 also to improve the position. I'm doing this because it speeds up the process in our next step. So number 1, also my second image. Here we have, in addition, number 2. So now I show the position of every marker on 2 images, and when I click next, I get here actually a nice wizard. The GCP with the name 1 is on 1, 2, 3, 4, 5, 6, let's say 15 images or something like that. So this is right, nice overlap, and because I select all crosses on at least 2 images, the positions here are already nice. So what I can do, I can use left mouse and move the images a bit even more to the centers. If I would like to eliminate some marker like this one, which is maybe not the best one, double mouse click and turn it off. If someone moves me the target and I lost the coordinates, I can disable this marker and so on. Okay, cool. I'm pretty satisfied with this result. I will click on next, and in the next few seconds we should get the accuracy of orientation based on 4 ground control points. Maybe just in the meantime, if you don't have a Phantom 4 RTK or Matrix 300 with a RTK on it, we always advise to use minimum 3 GCP points per project. But to have good control over it, it's great to have 10 ground control points per batteries. So you can cover the really great results already with this area, and it's super fast altogether. Okay, the accuracy is already here. So as you can see, this is in feet, 0.04, 0.01, 0.02, and so on. So it's super accurate. It's just not possible to do something like this with a total station or GNSS device. I will click in finish, And here we can see immediately our orientated model on those foreground control points. On the right side, we have all the statistics here. In addition, really nice one is reprojection error. This one should be less than 1 pixel in average per image. And here again, this table where we can control those accuracy. Actually, if you click here, you see accuracy per every image. So it's pretty technical. Most of users don't need this. They see here if those errors are small enough, are satisfied. But just to mention, you have full control over your project. So you have really reliable, safe, and fast results. Okay, so let's do now the third step, reconstruction step, and calculate the dense point cloud based on this information. So I will click on reconstruction. We have here reconstruction level, extreme, high, medium, low. By default is high, which is already perfect results because we get a bit more than 500 points per square meter. So this is really dense. You see really nice detail out of it. If you like to have even more points, you can go on extreme. If you like to speed up the processing, you can go on medium or low. Just for your feeling, if high takes 1 hour, medium is twice faster. It will take just 30 minutes. Okay, I will leave it to high here. For my 64 images on my RTX 2060 laptop NVIDIA graphic cards, it will take approximately 45 minutes. And I will leave it this selected, so calculate on NVIDIA, because it's just much faster and much nicer result. Less point cloud in comparison, less noise in comparison if you calculate the reconstruction on CPU. Okay, let's confirm it with OK, my settings, and we are back in a few minutes. Welcome back, and here we can already see our result of dense reconstruction, a bit more than 24 million of points. If I zoom in a bit, you can see pretty detailed estimation of terrain. So it's just not possible to do same results with any other technology. Even if you have a laser scanner, terrestrial laser scanner or something like that, you would need to stand maybe on 20 locations and you will still have some holes in on the upper side. So photogrammetry is just the strongest things if you're doing volumetrics. So, okay. And because we are here on our workflow presentation from images to 3D model and orthophoto, we will now continue with a full 3D mesh. Later on, I will show you how can you calculate volumes based on this data. But let's continue. As already explained, so we have point cloud here. Now we will calculate mesh. We have two options. The first one is regular grid mesh, which is perfect for volume calculation. We will use this a bit later. The second option is calculate full 3D mesh with texture. We will have this one. And then the third option, triangulate mesh from CAD data. It's also a really interesting one. With this option, you can actually generate surfaces if you have just GNSS measurements, so just standard 3D points or total station points, and you can do the Rooney triangulation, so those big triangles, and you can overcome these problems if you have already all data with traditional surveying and then combine them with photogrammetry measurements. And of course, you can load it and save it and so something like that. Okay, let's calculate new full 3D mesh. Here is our point cloud. We have just a single one, that's why it's here automatically. Here, we will do also texturing. You have some advanced settings here, like calculation level, how many triangles you would like to have, and so on. Let's leave it by default. It's more than perfect for us. And click on calculate. And this will take now approximately additional few minutes. The mesh calculation is pretty fast one, so if you don't need to have texture on it, you can also deselect texture, and it took you maybe 1 or 2 minutes, but we would like to see also nice texture on it, how nice and accurate our model is. That's why we also select texture on, and probably we will need 3 to 5 minutes for this model. And here we can already see our textured 3D model. If we zoom in again, pretty detailed, really nice one. And this is already good basis for calculation of a true orthophoto, which is our end step. So now we have point cloud, we have mesh, we still don't have orthophoto, so I will click on orthophoto, calculate new one. What we will also do, if we have buildings or something like that, we can define custom plane and calculate facade orthophoto or anything like that. So side orthophoto. In this one, we would like to have a top-down orthophoto. Let's leave the desired resolution to 1 inch per pixel. So this is pretty detailed. Let's click on calculate. This should take maybe less than a minute. So let's wait and see the result. Okay, a bit more to visualize it. And here it is, our true orthophoto. So even if we have buildings or anything like that, roofs are on the accurate location. Here we can see our markers, ground control points, and we finish actually with the workflow presentation. From 2D images, we calculate accurate 3D textured model, and now we can also see our true orthophoto. Of course, it's always great to save your project after you finish it and maybe generate a general report. With this one, you can quickly export a kind of doc file where you get all the information about the project, what you actually did. Okay, this is everything from our first step of the presentation. Let's go now and do the deep search and presentation. How can we calculate volumes of a stockpile and so on. Okay, let's go back live now. So this was a short video about the workflow from images which we copied from the drone. We did a bundle adjustment, which is the first step where we built the geometry together from images. Then we do the orientation with ground control points. We accurately orientate this model with a survey grade accuracy. Then we create a point cloud out of it, full texture 3D mesh and orthophoto. And our next step will be second part of the presentation, and this is how to calculate volume based on these results. Before we go to this part, I can tell you we have already 5 or 10 questions ready, so thank you for those questions. I will maybe wait till end of the presentations and then go questions by questions and answer it. So please continue writing your questions in the chat box, and I will answer them at the end of the presentation. Before we go further with volume calculations, I would like to set you 2 questions, so to see if we have a global audience here. And my first question here is, what country are you from? I launched this question. Just type your question in chat box so that I can see, because there is not possibility to type words in this chat box. And I can see it then right away here. Okay, we see you have Slovenia, Norway, Croatia, Indonesia, again Slovenia, USA, Hungary, German, Guyana. Okay, still coming Croatia, Germany, Switzerland. Okay, must say this webinar should be mainly focused on US. That's why the timing is a bit late for Europe, but I can see a lot of Europeans are also attending here. So We have Italy, Greece, US again, Swiss. Okay, I can say just thank you all for coming. Continue typing here your countries, and let's go with my second question. And second question is, which industry best describes your company work? So let's also launch the pool, and you have surveying, construction, mining, agriculture, and utility. Let me just inform you, we have 56 attendees, so quite nice audience so that we can get reliable informations about the construction, about the industry who are attending currently here. And I see 67% already voted, and currently result is 79% surveying, 11% construction, 5% mining. So definitely surveying wins. Thank you for your answers. And now I think we are ready for a part where I will present you a 3D survey software, how to calculate volumes and so on. I think you can already see my screen and this calculated model. So before we watch video about the presentation, now we are in real time. This is actually mesh result, and actually my full 3D mesh, the same one you saw it before in the video, but to calculate volumes, we advise you to use 2.5D mesh, so it's a regular mesh, which is actually more stable, more reliable for volume calculations. Why? Because in a full 3D mesh, you can maybe get some kind of balloons like in cables here. This can happen maybe if there is a high grass or something like that. Of course, it also works if you would like to calculate it, but we advise you so to turn off the full 3D mesh, go back to point cloud and calculate a regular grid mesh. So the option is here, but before we do this, I will also do the classification. Okay, why to do classification? With classification, we automatically eliminate the trees, buildings, machineries, cars, anything like that. Maybe in this area, this wouldn't be necessary, but to show you how it works, because it's super fast and works really nice, let's do it. So here on the right side, when I'm in a point cloud tab, I have my classify tool, and the classification window pop-ups. We have some parameters here, as already mentioned before, default good enough for 95% of examples. I will just click on next. Then the software is preparing point cloud for classification. What I need to do in this step is I need to select a single point on a field which is terrain. So don't go over track or buildings or something like that. Click with the left mouse click on a terrain point, and we can see the software already recognize most of the terrain points and color thread. When I go to the next step, the algorithm additionally automatically try to recognize the terrain points, and in these steps everything looks pretty fine. I will click on finish, and I'm in my main window. I can see I lost maybe a few points here on the edge. How can I improve this? One option is go back and change the default parameters a bit. Maybe faster option, use the select function and just additionally select those points in addition. So when I'm selecting, I'm using the left mouse clicking, and finish my selection with right mouse click. Okay, in this way I can easily select my points which I like to add them to the terrain, and then we have option delete selected and delete other. instead of delete selected, I will click delete other and just eliminate all other points from my point cloud. Okay? Don't worry, when you delete points, you never lose anything. Here you have undo and redo, so don't worry. Okay, if I click on clear, I get my realistic colors back, and this is already perfect data type for calculating regular grid mesh. So I will go calculate new regular grid mesh. Here we have point cloud based on which we are calculating. Because we have just a single one, we don't need to change it. Then grid cell size, I will use 1 feet grid cell size, whole filling mode all, and one cell size smoothing. So those two are standard ones. And click on calculate. And right now we are calculating regular grid based on 22 million of points. And here we can see a nice smooth surface which is ready for volume calculations. Here we have different view styles available. So I turn on height map and shading. So you can see really nicely, really detailedly what kind of field you are working with. You have also show grid options, just to show you. With the regular grid, we have actually regular grid mesh with 1 feet. Okay? Perfect. Let's turn this one down. And then what we can do is the first way how to calculate volumes. So I will show you now 3 ways, but in this project I would like to show the simplest one where we have just a single surface, we have a regular grid mesh, and I will just go to my polygon selection and start with selecting my area of interest. During the selection I cannot actually rotate the model, but I can select it more times. So this is my first selection. Now I rotate it and I see maybe if I turn on height map and shading, I will be more effective. So let's do the selection in this way. Okay. Okay, this is it. Looks nice, maybe a bit more here in addition. There is also option to do the deselection. So if I go to deselect, I can deselect this part which was selected too much, and also maybe this one. Let's see here. I need to select here in addition. So height map and shading helps you quite a lot in these cases. Okay, cool. I'm pretty satisfied with this selection, and there's nothing more than click on calculate volume. And in this case, when we have a single surface, we actually interpolate the lower surface. Okay, so we can also switch those two if you would like to change between cut and fill. So fill and cut, you can change those two here, but by default is initial surface interpolated surface, and final surface is our point cloud surface with a regular grid mesh. Okay, from current selection, and we are already calculating volume of this stockpile. Because the mesh is pretty small one, this will take probably half a minute or something like that. So let's just wait for the results. And right now we are doing the interpolated surface below, comparing the results with the upper surface. And here we can see already our volume. I will just rename it Stockpile 221. And we can see it here. We have a fill of 132,000, actually almost 133,000 yards, cubic yards. We have some cut where the interpolated surface goes over our realistic surface, and then we have a total value. We see also 3D area, 2D area, everything like that. Okay, when I click on OK, I can see here my realistic surface, and right above it there's a volume. And if I go also to my orthophoto tab, I can see this result on the orthophoto. Colors from yellow to red are actually fill materials, and here blue colors are cut materials. You can additionally see this volume in a volume tab, which is optimized for volume visualization. So we can see now here clearly the surface below. We see it's nicely interpolated. It's not fully flat. So we actually look for the points around the model, around the selection, and try to create the smoothest surface. So this is really important. In this way we get the most accurate and reliable results. Then here is interface where you can change few things. For example, what you could do, you could change colors if you like. So let's go to green, something like that. You visualize it different way. Then we have some kind of buffer zones. So here where we have a realistic color, this is between 0.07 feet and plus 0.07 feet. So here no change were done. Actually two surfaces cross them together. We can increase this or lower it, anything like that. Okay, and then what you can do with this, you can save this as a quick report, but I would like to show you this a bit later after we calculate also profile lines for this stockpile. So this is it. In a couple of minutes we select it, we calculate the volume, and we get the most accurate results you can get it. And you can see it right here. Okay, in addition, when I'm moving over my stockpile, I can see before surface 5,102, after surface, and then how much fill and cut material. Okay, so everything is written nicely here. So no better option to visualize your volumes. Okay, let's turn off this volume and go back to my point cloud. Sometimes you need additionally maybe cross sections or profile lines. So I would like to really quickly just show you also this option. Those are again standard parameters, some technicals, so how many points you would like to have when we calculate the profile, and how long should be the segment between 2 points. This is good. And then we would like to have cross sections. So I would like to select the main line and then visualize the cross sections every 30 feet and then 150 feet left and right from my profile definition line. Select profile definition line and just define it like so. Okay. I see 21 profile lines or cross sections will be calculated. Let's zoom in here. We can see red lines already. If I turn off the point cloud, we can see them in 3D. If we go to orthophoto, we see them also on the orthophoto, how they were calculated. And of course, here we have a profile tab. The first one is our longitudinal profile, and then every 30 feet we have cross sections like here. Okay, as I already said, I think it's 21 profiles. We can export this as a PDF or DXF and import in AutoCAD or similar CAD softwares. We can do some editing on it. So if we need to change point, double mouse click and improve it, something like that. So all the tools are actually available here. Cool. Let's go back to our point cloud view, turn on the point cloud, and now after we have point cloud and volume, we can export some kind of technical report. It's so-called measurement report. I will select both of two topics and create it, and as a result we get automatically generated Word document. Let me just quickly open it for you. And here we can see, so the volume measurement, volume calculations, all important data, and on the orthophoto we can see the position of our selection, and then our second part, profile lines and transversal lines, so cross sections, and all important points here which are necessary, and of course the graphs in the document. So you can easily save it, export it, edit it, anything like that. Okay, cool. So this was my first example, the fastest and the simplest way to calculate out volume. Right now I would like to open a new project. Before I go to the new project, I need to change my units to metric, because this one, the second one project, is from Canada and they use metric values, so I don't need to save this one. Let me open the new project, just double check it. Yes, metric, it's okay, and the new one is here. So similar site, but in Canada. This is example from from another customer. He used Matrix 300 for data acquisition. This is the sparse point of result. As you can see, he used quite a lot of GCP targets for orientation. Actually, it's always good to have more, that you have independent accuracy and so on. Here we have a point cloud. We already see also some drawing CAD data in 3D survey. And here we have mesh, again regular grid mesh, which is the best one for volume calculation. And here I would like to show you the second approach to calculate volumes. So instead of selecting your area of interest, you can actually draw CAD lines and define the volume calculation area based on this. What's the benefit of this approach? The benefit is you can save those CAD lines, and if you need to come back and again measure the same area volume calculation, you just import those CAD lines and that's it. And another benefit is you also have a boundary area. Sometimes your investors ask you, can you send me the area on which you calculated? You just send this like a sketch or anything like that, and you have it there. Okay, so let's go first to my cat, and here we can see I already draw two closed polygon lines for those two stockpiles. Now I will create the third one for this one. I would like to draw, currently I see point cloud and mesh, so I would like to draw on textured mesh or on my regular grid mesh actually. That's why I turn off just regular grid mesh. Let me see if shading helps. I think I can handle also without. And go back to cat. And here create a new layer, X material, I don't know what this is. Let's make it layer active, set the whiteness of line to 3, and I will use let's say blue color. Then I will select my draw line tool and I will snap on triangles and endpoint. I don't need display, so distances. So what I'm going to do now, I'm just going and draw the CAD lines. What's the benefit also here? Here you can actually rotate and zoom in with the help during the selection also. So this is another benefit in comparison to calculating the volume with the selection option. At the end, what's important, I need to close my polygon line. Okay, so how can I check this? If I go to select tool and select my closed polygon, here it's written closed, yes. If this line is not closed, the volume is not going to be selected. What's in addition, if you already have those lines created from another external software, or maybe someone sent you, okay, I would like to have that you calculate me volume on these specific areas, you can import this as a load CAD option and just import the XF file inside of the 3D survey, and it will work. Okay, for your information, doesn't need to be a 3D line, works also with 2D lines, so we just look for the horizontal position of the line. Okay, now when I finish with my CAD drawing, I can go back to mesh. We have a regular grid mesh. Click on calculate volume. Now I will do from CAD and use those three layers. Click on calculate. As you can see, areas are already colored red, so it means they are in selection. Again, we use a single surface for the volume calculation, so it means we do the interpolation of a lower surface, and in a couple of seconds we should get the results of those 3 stockpiles. Okay, so volume area 40,900 cubic meters, sand 11,000 cubic meters, and X material 8,000 cubic meters. Here you have a total value 342 cubic meters. If I close it, we can see it here. Also, the visualization is a bit better if you do with the CAD lines, because you don't have so much white lines which are connecting a realistic surface with the volume surface. So I just like this way a bit more. And then again, you see everything this also on an orthophoto, and you see everything this in a volume tab. Okay, right now I'm going to delete those volumes. This was my second example. I see we are tied with time, so let's go really quickly to my next presentation of volume calculation, how to do it. And in this case, it's pretty typical problem. So maybe you are still not working with photogrammetry, you are measuring terrain with the GNSS or total station, and you already have measurements done with this technology, and now you need to compare it with the photogrammetry, and this is super difficult in all other softwares, but we did it really elegantly because we support also surface generation just based on GNSS points or total station points. So I will turn off my regular grid mesh. I will go to my point cloud. Here is existing one, and now I will load my points which were measured actually 2 years before with the GNSS measurements. We see point name X, Y, Z, local coordinate system, import them here, and I have them here. Let's turn all other layers down. Cool. These are my 3D points, maybe smaller. The text size really quickly to 6. Okay, so those, let's say 100 points were measured traditional way, and now I need to generate surface out of it to compare it with the new photogrammetry measurements. And how can you do this? I import this as a CAD measurement, and now I will go to my mesh, triangulated mesh from CAD data, and select those points, click on calculate, and in seconds the software generate actually with the help of the Lunin triangulation my traditional surface. You see the triangles are quite big here, but when we measure it with the total station or GPS, we measure it every 5 meters or something like that. So this is pretty decent. Then what I could do in addition, I could create some break lines. So maybe because I see the mesh was here not perfectly connected, probably we have, okay, like here, what I could do if I go back for half, turn my point cloud on. This is from new measurement, but probably in this part didn't change anything, and go back to CAD. Let's do in the same layer also some break lines. Snap to this point at this point, because we see this is the bottom of this terrain, and also probably from this one. So, oh, sorry, 2 lines. Okay, just to see the effect. So I create actually two break lines, and if I go again and do the triangulated mesh from CAD, and now I have also those two break lines. Turn off the previous model. Let's see. Yes, it works much better. Okay, I would need to draw also here, but even now we see before how it goes here, the connection. So with the help of mesh calculation, with the break lines and points, you can achieve perfect model. Let's say we are satisfied now because the time is already 6, and turn on the regular grid option. So here we can see now, okay, our lower surface is black because the points were in a black-white color, but nevertheless, let's turn on realistic colors. And now I can compare my measurement before 2 years and measurement which was measured a month ago or something like that. I did the selection, calculate volume, those two selections, and okay, need to define differently this surface. Oh yeah, because it's a full 3D, it's a full 3D mesh. Okay, what I need to do in addition is convert this one to point cloud. Okay, it was right click on the mesh, and even I will have nice colors here. And now mesh, calculate new regular grid mesh. Let's set it to 5 because it's a traditional survey, don't need to be so detailed. And here we have no traditional surface. Let's name it GNSS surface and our realistic surface. Okay, much better now. And just quickly select our area of interest, upper surface, lower surface. I'm in between those two surfaces. Okay, not sure if you can see so nicely as I can see, and calculate volume from those two surfaces. So now everything will work, and here we have a cut material. Why cut? Because my surfaces is, the first surface is realistic, the second one was designed. Let's even repair this one, just calculate volume again and switch those. So my GNSS surface, lower surface, and this one. Again, the volume, no, just the cut and fill volume should be changed correctly. So we have 147,000 cubic meters of material. And we see this one also in a volume tab. Here it is. Okay, cool. Correctly, yes. Now we have we see the results in meters because its project is in Canada and I set it in metric units. So that's why we can see it here. Before surface 364 meters and after 375 meters. And here almost no change. Okay, guys, this is more or less everything for today's webinar about the presentation. I need to speed up a bit because a lot of interesting things to say you, to explain you, and so on. But before we finish it, we have a Q&A session. So let me just quickly check what kind of questions we have here. Okay, the first one is 3D Survey Pilot app. Is the Mavic Air Phantom 4 RTK supported? Okay, so we have 3D survey software, which is our main product, and then we also have a pilot app. Let me show this one. How to move it? We also have a 3D survey pilot app. So this is the software. Where's the application? Okay, so we also have a 3D survey pilot app. Yes, and it works also on Mavic 2. It works actually on all DJI drones, just not on Mavic Mini because the SDK is not supported. So feel free to use it, but it still not work on RTK, the Phantom 4 RTK. This will be supported in next 3 months. So we will add these functionalities in addition with the 3D survey pilot app, and will be supported also with the RTK. Yes, but if you're using the Phantom 4 RTK, you have already integrated app from DJI, works nice, so feel free to use this one. Okay, then another, this was question from Jürgen Jakob, and now let's go to the new question from Engi Yuan Liu. We are trying to choose between the Phantom 4 RTK and Phantom 4 Pro version 2. Both require CP control points. With the Phantom 4 RTK require less CP. That's true. For us, we think the P44 will have managed the health check for validity. Okay, what are your thoughts on this so that we can choose the right drone? Okay, so we have Phantom 4 Pro and Phantom 4 RTK. Both, they have a same camera. There is just one difference. The RTK has an RTK antenna on it, and it works perfectly also in accuracy. So if you have more projects, I definitely advise you to buy Phantom 4 RTK because it costs, let's say in Europe, I know prices for Europe, it costs you 4,500 euros. The standard Phantom 4 Pro costs you 1,600 euros, so it's not so much more expensive. And if you have a bigger site, so let's say like 500 by 500 meters, you're at least 3 to 5 times faster, okay? We did a lot of tests with both of the drones. We finished more than 500 projects with those two. I would say if you have bigger areas, the Phantom 4 RTK is super efficient. Of course, it also works with the Phantom 4 Pro, and just for comparison, if you have area like 1 per 1 kilometers, with Phantom 4 Pro you would probably need 20 ground control points. With the Phantom 4 RTK you need, in the best case scenarios, in the worst case scenarios, just 4 control points. In most of cases, just single ground control point helps you with the calculation. We did also measure a test if the RTK works without ground control points, because I know a lot of software providers also tell you, yeah, you don't need ground control points and so on, but it's not actually true, because we did a test on the same field 10 times with the RTK, and I can say 4 times we get accuracy up to 4 centimeters, I mean 3D accuracy, and the other 6 times there was a displacement in height for 20-25 centimeters. So even when we use just a single GCP point in addition, we improve this displacement. Horizontal position is always perfect, but for height we advise still to use just at least 1 to 4 ground control points per project. So I would advise you RTK if you have a lot of projects. If you're doing this stuff once per month or once per 2 months, then take the Phantom 4 Pro. Okay. Okay, what was the height? Next question from Chris Robbins. What was the height of the first project? I think it was a 60-meter flight. Most of the flight our customer doing from 60 or 80 meters. This is the most efficient way. Okay, then we have countries. Let's switch this part and back to questions. How to calculate and predict of waste dumping modeling on landfill area based on drone or to photo. Waste dumping modeling. Okay, not sure I understand you correctly, so maybe I will contact you at the end of the webinar and explain this to you in addition. Okay, but if you need to calculate the volumes, you already get the answers. Otherwise, we will contact you. Okay. Okay, then another from NG Jungli. Can volume units be changed when needed? You can see how I change the volume units. The problem is everything it's calculated from the data, so you need to change it in general settings, option, application settings, and go to imperial or metric. When you go to imperial, you have two options, US food or other, or actually three options. In our case was US survey food. When I confirm it, I need to close the software and turn it back on. Okay, so you cannot change it in real time because of the software system. You need to do it that way. But usually users are always calculating in the same units for a lifetime, so you did it once and that's it. Okay, let's go back to questions. Love the report, thank you. So yes, in this year we'll even improve this. Can't wait to have it. Okay, you had mentioned that 10 control points per battery on a non-RTK was recommended. How many would you suggest? Okay, Eric, I already explained this one in previous one. For the RTK, I would put 4 ground control points on all corners. This gives you independent accuracy and super accurate results. If you have a muddy area, or I don't know, there's a water, or you have a garbage dump, place at least 1 ground control point where you start with the drone, and I'm sure you will get the accuracy in the 99%. But as a surveyor, you know, you always try to have independent accuracies, so place 4 of them. Okay, the next question from Benjamin Rabish. How does the classification tool work on query with a lot of vegetation? Works pretty super. So the classification in 3D survey is really easy and really effective one. I know US customers, they really like it because from competitive softwares it's more complicated and not so effective. So just try it, contact our support team if you will need help. The most problematic are small grass or something like that. If you have trees or anything like that, works perfectly. And nevertheless, you can also classify the LiDAR, airborne LiDAR data. So you don't need colors from point to do the classification. So if you have a terrestrial laser scanner, feel free to go. Okay, another question from Eric Evans. Have you processed any data from the Matrix 300 with a P1 camera? Not yet. Oh, we actually did, but I don't have results. We get the first data set yesterday. My colleague was on the webinar from DJI with a P1 camera. I would say the Phantom 4 RTK stays still the best selection for surveying purposes because it's small, it's reliable, powerful. The camera is good enough. I know the P1 have just more megapixels, but if you fly up to 100 meters, you don't need them, okay? With the Phantom 4 RTK on 80-meter heights, you get resolution of 2 centimeters, and this is more than enough in most cases. If you like to have better accuracy, you can fly lower. So Matrix 300 with the P1, nice setup if you have more money, really good one. And what's the benefit of this setup is definitely you can change cameras. It's more drone for inspection or something like that. So and of course also maybe for really, really huge areas, probably the battery time is a bit longer. Okay. Are there limitations for point clouds? What are the limitations? So depends how many memory you have. So when you load in the point clouds, you can easily load in about 200 million of point clouds. The memory is here important. If you have 128 gigabytes of memory, just go on. Okay, the hardware is limitation. What we do a bit of trick with the presentation. If you have a big point cloud, let's say like 200 million of points, we just visualize 50 million of points to work more efficiently doing the rotation, visualization, everything like that. but with the 50 million of points on your screen, you see more than you actually need. But if you go to calculate out anything like surfaces or anything like that, all points are taken in calculations, so all 200 million. Okay, then another one questions, what is the most optimal flight height for P4 RTK? I would say for stockpile measurements or project like this, I would take, I would use 80 meters from starting point. If you have small areas, really small one, go to 60 meters. If you have some 3D modeling, visualization or anything like that, go close to the model up to 10 meters, 20 meters, okay? Then another questions from Benjamin. How is the performance of the GUI when a point cloud is portrayed? It looked a little bit laggy on my end. Not sure if it was due to the capturing. Yes, so the rotation of the point cloud was really, really smooth. If you don't have a software yet, download the trial and you will see. It's great if you have a NVIDIA graphic card, so not integrated graphic cards from Intel. This will help you, but works super smooth. This is because of the internet. When I'm doing everything, it takes a couple of seconds to show you on your side. Okay, and then the last questions from Slovenia one. Do you expect improvements in battery quality, working time? We use Phantom 4 RTK. Not sure, so it's a drone question more, Andrei. So the flying time for drones currently, I think 25 minutes, it's realistic. By papers, it's 30 minutes, something like that. But I would suggest you to buy additional batteries when we do some big projects for testing or anything like that. So we have 10 batteries in pack and you can easily map more than 10 kilometers of road in a single day. Okay, I think these were all my answers to your questions. There is one in addition, Marvin Gabler. What is the best angle for capturing piles like you showed in the presentation, 30, 45 or 75 degree? So in piles like this, 90 degree pointing camera fully down, it's more than enough. Okay, you don't need front view or anything like that. This is more important if you have some kind of option, some kind of houses with some details under the roof, or you would like, or you have a lot of trees and you would like to have point cloud under the near the tree or something like that. Just go perpendicular to down, single grid flight, and that's it. Okay, nothing more. So I can show you here on our YouTube channel where we have a pilot app. So videos. Here you can find all interesting points, interesting videos. So this is the simple mission, grid mission. You don't even need to do a double grid mission, which is more important when you are doing nice 3D models or something like that. Okay? Cool. If there are any questions, feel free to contact us on our support@3dsurvey email. You can also call us. We are maybe the only ones who still have a phone number on our webpage. So if you scroll down it, okay, let's turn off the, where is contact support? Here it is. So you can call us, you can write us, anything like that. We have also Skype, WhatsApp, all the platforms. Thank you for attending this webinar. So we are already 20 minutes past the timing. Feel free to download the free trial and start 3D surveying today. Thank you for listening. Feel free to contact us if you have questions. Bye.